I've just brought my slides up here. These are not critical. They're just mostly prompts to remind me what I wanted to say. So don't worry about them too much. Thank you for having me here today and giving me the chance to speak to you all. It's really a lovely opportunity to share a little bit more about the work that I do in Stargardt. And thank you all for joining. Those of you that could come live today, I appreciate there are probably other things you could be doing in the nice weather. But if you're anything like me, it's probably blinds closed, fans on to move the hot air around kind of situation. But glad you could make it today. So the study I'm talking about today to you is all based around retinal imaging, specifically in Stargardt's disease. So before I go too much into the study itself, just a little bit about who I am. You've already heard from Rosie vaguely who I am anyway, but I qualified initially as an optometrist back in 2013. I then was a glutton for punishment, went back to university again, back to Cardiff, and did my PhD. My PhD was in macular disease, but it was mostly focused around age-related forms, but it was all around, again, imaging of the eye in AMD. I then took up a lectureship in Cardiff, so I'm very Cardiff-centric. They can't get rid of me, and that's where I still am to this day. So since 2017, I've been lecturing in Cardiff and doing research as a part of that across many different fields, which you probably just heard. There's a lot of other things I do aside from macular research. There's a photo of me on the slide here giving a rather overly enthusiastic talk with some colleagues at a university in Ghana, all based around kind of networks to support women who were aspiring to take up vision related roles. So lots of different things that I do, but really pleased to be here today to talk about this particular work that I'm doing. Alongside me on this project is Professor Marcella Votruba. She is based in Cardiff with me. She's partly at Cardiff University, where she was a previous head of school for 6 years, and she's partly based at the hospital in Cardiff, where she is a consultant ophthalmologist, and she leads the Welsh Ophthalmic Genetics Service. So if you were based in anywhere across South Wales, more or less, there's a good chance you would have met Marcella at some point. But she is a fantastic support on this project as well. Just a little nod to our funders of this work as well before I go any further. So the project itself is funded by the Macular Society, and that is via the Daphne Jackson Trust, who provide a fellowship to me to do this particular work. So it's a fantastic team at both of those places. So a big thank you to them as well. So what are some of the current problems we have in Stargardt's disease research specifically, and what are the kind of gaps that I'm trying to fill with this project? So the first big one that we have is the way that we measure visual function, so measure vision effectively. These eye charts, you've probably all come across these at some point, probably multiple times, reading the letters, where are they? Can I make them out? Am I given long enough to try and find out where they are and what they say? There are lots of problems with this traditional measurement. We've been doing it for years and years and years, and it's not particularly changed during that time. One of the big problems we have with these letter charts is the variability in the measurements that we take from them. So from day to day, you probably find the letters you read are quite different. Sometimes you read a bit further down, sometimes not. A lot of other factors contribute, like lighting conditions, how long you're given to try and seek out the letters. All those kinds of things can make a big impact on the actual number of letters you're able to read on the day. So they're not the most consistent measurement, but they are at the moment one of the main outcome measures that things like clinical trials will use to say whether there's been a change or not in a person's vision. So they're still what we use, but they're not perfect. The other big issue we have at the moment, we have absolutely fantastic ways of measuring structure of the retina. So we can take photos, we can take scans that give us a really nice detailed view of somebody's retina. And we can use that to monitor it over time, see if it's changing, see where it's thinning, what's happening exactly. What that tells us is only the structure of the retina, so what the retina is looking like. What it doesn't tell us is how the retina is functioning. So how much of that retina is actually working. And if it's working, is it working at full capacity, or is it kind of got a reduced function in these areas? So we have this disconnect between structure and function. And like I said, structure, we've nailed it. We can measure that really, really well. Function, we're just not quite there yet. And you do get these cases where actually structurally on the scans, the retina can look pretty good, but when you put them on the letter chart, the letters aren't so good, and there's this disconnect between the two. And we get the converse as well. Sometimes the retina looks, not in a good state at all, but reading the letters seems pretty good. So they don't always tie up very well, and we want to plug this gap in the function part of that equation. So what are we looking to do with this research? So this is kind of the earlier stage of clinical research. It's not one of those sexy clinical trials where we're aiming to fix people's vision. This is more about increasing our understanding of what happens in Stargardt's disease. Exactly how the retina degenerates, exactly how the function changes over time. So just getting a little bit more understanding behind the condition with a view to then being able to address those underlying issues later down the line. We want to do that really by characterizing a little bit more about retinal function. So because we don't have a great outcome from that letter chart, we want to know in more detail what happens to the retinal function over the course of Stargardt's disease. So how does it change? Does it dip? Does it fall gradually? Are there particular locations of the retina that are more quickly affected function-wise, not necessarily structure-wise, in the condition? And then finally, we want to monitor those changes over time. So we know at a particular snapshot what the vision's doing, but we want to know in more detail than we currently can with the letter chart how that changes over time. So over, say, an 18-month or longer period, can we monitor very small changes in the retinal function during that time course? So there are our main aims. We are hoping to address these with this new shiny device, which we call densitometry. We are very lucky in Cardiff because we have the only densitometer in the world. It was built as part of a collaboration between Cardiff University and the UK Astronomy Technology Centre based up in Edinburgh. So I like to think of it as being quite space age. There's a surprising overlap actually between astronomy and optometry. It's all to do with the optics of the lenses and stuff that they put in telescopes. But I think that's pretty cool anyway. So we have this densitometer in Cardiff now. It's already being used in a clinical trial in age-related macular degeneration. And we want to now investigate it for the first time in Stargardt's disease. And that's what we've got going underway now. So this is quite different to other forms of imaging that we have. It doesn't do structural imaging. This is all about the functional, quantifying the function of the retina, specifically the photoreceptors, those light sensitive rods and cone cells that we have in the retina. What the densitometer looks like really is a picture of it here. It's essentially a funny shaped grey box plonked on a table, and it has a chin rest like most of the other kind of scanners that we use in ophthalmology. Start to finish, the measurements that it takes take around 15 minutes, and there's nothing overly invasive. It's just looking inside the box, staying as still as you can while it takes a series of measurements. And the really nice thing about this device is it doesn't require any responses. So there's no buttons to click. You don't need to say what you're seeing, nothing like that. It's just a case of staying still and watching straight ahead to the best of your ability. But we've had some really nice results from it so far. It seems to be working really nicely, which is always very, very reassuring. So densitometry is what we're using to try and plug this functional gap and finding out more about how the photoreceptors are functioning. Now, when it takes its images, it takes them over space. So it effectively plots a map of the macula region, and it shows which areas the rods and the cones are working well in, which areas they're not working so well in, and so on and so forth. And then that map can be tracked over time, so between visits, to say, yes, this area is changing, this area is stable, here's where the good bits of vision are, here's where the not so good bits of vision are. And these are very, very sensitive measures that it's taking as well. So there's a lot of promise. We have a lot of hopes riding on this densitometry device. So like I said, we're very fortunate to have it in Cardiff, and we're trying to make the most of it and find out the most information that we can while we have it with us. So densitometry is the main part of the study that I'm conducting. What else is involved in it for people who take part? We use dilating eye drops. So anyone who's in the hospital eye service will no doubt have had dilating eye drops before. So you'll know exactly what these are about. They're the same ones that are used at the hospital, but we need to have a nice dilated pupil for these measurements to be effective. So we do a dilation at the start. And then we do a series of other imaging as well. So similar to the ones, again, that you probably had at the hospital if you've had any before. So things like photographs, infrared, autofluorescence, if you've come across that before as well. That's a very common one used in Stargardt's disease. And on the picture here, I've got an OCT, an optical coherence tomography image as well. So we're doing all of those as well, the kind of classic clinical workup just to compare back to our densitometry findings so we can tie up that gap between the structure, which is what all of those photos and scans do, and the function, which is what the densitometer does. We have one initial visit, which is what I'm conducting now, and then people will be invited back 18 months later for a second visit. That is not obligatory, so if people are unable to attend that, not to worry, but the idea is that we can then compare the two visits and see if there are any subtle differences in a person's functional vision between those two sessions. So we're hoping that the densitometer will pick up very small differences within that 18-month period. So that's the reason for that second visit. And it's essentially exactly the same as the first one. We just do all the same stuff again. So what's our end goal? Why are we trying to do all of this? Like I mentioned earlier, our first aim really is to characterize that retinal function in more detail than we currently have just from the letter chart, which is just a real snapshot of how good the vision is at one moment in time. And like I said, it's quite variable. So this is a really sensitive, highly detailed map across the macula showing us exactly how the retinal function differs between locations across the macular region. So really detailed, really sensitive. We then want to, like I said, with this 18-month visit, see how good the densitometer is at detecting these really small changes over time, again, by location. So we might find that some locations change quicker than others. We might find that ties in with what the structural scans are doing, or it might not. We don't know until we've done it. So that'll be quite interesting to see as well. Obviously, we're not expecting those results until, a couple of years down the line when we've collected the follow-up visit. But watch this space if you can wait a couple of years. But the really big overarching goal for us really is to see whether the densitometer has potential use in clinical trials of Stargardt's disease. So if it can pick up these really sensitive changes, that would be a really strong measure for seeing how potential interventions can change the vision over time. So at the moment, if we're using the letter chart, there's quite a bit of variability in that. If we can use a really sensitive measure like densitometry, we can say in much more detail and with more certainty exactly what effect those interventions are having on a person's vision. And on an individual person's vision as well, not just a kind of group collective. So it's potential use in clinical trials for monitoring change, showing whether an intervention is working or not, could be really, really valuable. So that's our main goal of this. I had no idea until yesterday when I was writing these slides that the retinal densitometer we have has a logo. So I felt I had to put that in. Who knew it had a logo? But there it is. It's a nice red and blue eye-shaped logo that says retinal densitometer. So where are we going from here? So after we've completed this initial visit and then the 18-month follow-up visit, so around the time we're bringing people back in, we will also start the next phase of this study. So at the moment, we're recruiting people with Stargardt's and a control group to compare between the two groups. In the next phase, we will be inviting people who are carriers of the genetic variants for Stargardt's. So primarily biological parents of people with confirmed Stargardt's disease. And the reason we're interested in carriers is because they don't typically express any signs of the condition. Normally their vision is typical. They don't have any known symptoms and nothing that measures on our traditional clinical tests, but they do still carry the genetic variant. So we're wondering if there are some kind of very small, subtle subclinical differences that can be picked up with a very sensitive measure of retinal function. So like the densitometer, again, we'll be using the same equipment that we're using now to look for these really small differences, potentially in people who carry the variants versus people who don't carry the variants. So even though they don't express the condition themselves, do they have something very minor going on behind the scenes? And that's where this study is really going to answer some questions, because it's just not been looked at before. Traditionally, carriages are just overlooked in research because they don't have the condition themselves. So they're just kind of tucked aside, and the focus is understandably put on people who do have the condition. But we want to understand a bit more about the mechanisms behind it. So that's where this study will come in. So 18 months or so down the line, we'll be putting out another kind of advert through the newsletter just to let you all know that this study is starting recruitment. And do feel free to get in touch if that would be something of interest, or you know somebody who would like to know more about that when the time comes. But we'll be opening that probably towards the end of next year, so late 2027. That is likely to start opening to recruitment then. So again, it's another watch this space. Sorry, I don't have any flashy results to show you today. And that's really all I have to share in terms of the research and what it's about. I just need to say a really big thank you to everybody who is taking part in this study or other forms of research. I think really taking part in research is the only way that we can move forward with things like understanding and interventions, because if we don't have volunteers to take part in these, we just get stuck. We get to a roadblock where we can't move any further with our research and with our understanding. So a really big thank you to anyone who has taken part already or who's interested in doing so. My contact details are always open, so feel free to email me whenever if there's anything you'd like to know more about my study in particular, about taking part, or about research more generally, or what is involved if you wanted to volunteer or join our database of volunteers as well in Cardiff that we hold. So any of those things, please do reach out. My email has gone out on the newsletters and things, but if you've missed it, it's terryl1@cardiff.ac.uk. So please do feel free to get in touch, and I would be more than happy to have a chat with you and answer some questions. But otherwise, I'm happy to stay on now and answer some questions directly for you. So yeah, that's all I have. Thank you.
Thank you so much.